Our modern world runs on an infrastructure that often hides its own origins. We live in a society that spent centuries devaluing marginalized people while relying on their uncredited creations to function. The common narrative suggests that industrial progress was a select, monolithic achievement. Yet legal frameworks like the one-drop rule were specifically designed to suppress the very brilliance that was driving the country forward. Genius proved difficult to contain. Despite being banned from laboratories and stripped of early patents, these thinkers engineered the foundational layers of modern civilization. The simple act of turning on a light depends on a solution Thomas Edison couldn't find. His original paper filament burned out almost immediately. It was Lewis Howard Latimer, the son of fugitive slaves, who engineered a durable carbon version. This innovation made incandescent bulbs burn safely and cheaply, allowing for the rapid electrification of cities and making artificial light accessible to everyone. As cities grew brighter, moving through them became hazardous. Early transit systems lacked coordination, leading to frequent collisions between carriages, steam trains, and pedestrians. Garrett Morgan and Granville T. Woods brought order to these dangerous environments. Morgan invented a traffic signal that added a yellow warning position to prevent vehicle crashes. Simultaneously, Woods developed an induction telegraph that allowed moving trains to communicate with stations, preventing countless railway wrecks. Even the way we move between rooms was redesigned by a teenager. In 1878, 16-year-old Osborne Dorsey patented the internal latching mechanism that created the modern doorknob. Every time you flip a switch, stop at a traffic light, or turn a doorknob, you are using infrastructure built by the people history tried to ignore. This ingenuity saved lives as directly as it powered cities. During World War II, Dr. Charles Richard Drew developed methods for the long-term preservation of blood plasma, organizing the first large-scale blood banks. Earlier, Dr. Daniel Hale Williams performed one of the world's first successful open-heart surgeries. Without modern antibiotics or transfusions, he opened a patient's chest to repair a torn pericardium and saved the man's life. In 1951, doctors took a sample of Henrietta Lacks' cells without her knowledge. These HeLa cells became the first immortal human cell line, providing the testing ground for the polio vaccine and modern cancer research. These pioneers engineered medical salvation and prolonged human life for a society that continued to build systemic barriers against them. Look at this model of the Earth. To make GPS work, you need a precise mathematical model of its irregular shape. Dr. Gladys West programmed early supercomputers to calculate this data. Today, every instance of turn-by-turn navigation relies on her mathematical backbone. Personal computing relies on the engineering of Dr. Mark Dean, who holds 3 of the original patents for the 1981 IBM personal computer. He co-created the system that allows you to plug a mouse, keyboard, or printer into a PC. Telecommunications moved forward through the theoretical physics of Dr. Shirley Ann Jackson at Bell Laboratories. Her research enabled fiber optic cables, the invention of caller ID, and the touch-tone telephone. Modern digital life, from personal hardware to global telecommunications, rests on the theoretical frameworks they designed. This drive to invent remains a constant force. 13-year-old Kelvin Doe grew up in Sierra Leone without consistent electricity. Using soda, acid, and metal scavenged from local trash, he built his own batteries, a neighborhood generator, and a broadcast radio station. Technical brilliance manifests wherever human necessity exists, regardless of formal invitation or wealth. This same drive pushed humanity into orbit. The space race relied on the human computers at NASA, specifically the work of mathematician Katherine Johnson. She calculated the curve of the orbital trajectories required to safely launch the first Americans into space, and manually verified the early electronic computer data. Simultaneously, Mary Jackson fought to attend segregated classes to become NASA's first Black woman engineer, removing barriers for women of color in STEM. The reach of this legacy moves from the orbit of the Earth to the microscopic resistors inside a human chest. Otis Boykin dedicated his career to electronics after losing his mother to heart failure. He invented a wire precision resistor that could withstand extreme environmental changes. That innovation became the control unit for the cardiac pacemaker, regulating the heartbeats of millions. The work of these pioneers functions as the central nervous system of modern human existence. Their legacy is a testament to perseverance against an oppressive system, stripping away the illusion of who truly engineered our world. They built the world,